Good afternoon, everyone. Are there any questions? Yes. You.
So on the website, there was like confusion about the draft and the final.
Yeah, I understand that. So I'll fix the website. Yes. Yeah. Yeah.
So the draft, does it have to be word for word for the class name? Right?
Yeah, that would be a problem. So here's what's going to happen is that the grader is going to run exactly the same program as NetBrat runs. So in that case, your file would not compile, and the grader would probably give you 0 points. So you do have to be careful when you submit those files. Now, what I've seen some people do is that they kind of treat NetBrat as if it was the development environment. And so instead of doing their work in BlueJ, they go to NetBrat and then they keep fixing it in NetBrat, and then sometimes they forget to paste it back or whatever, and that's really not what NetBrat was intended for. So the idea is that you should be using BlueJ, and you should be getting your program to work in BlueJ, and when you're reasonably sure that you completed the task, then go to NetBrat and then try it out there. Now there's one caveat to that. There were a few people who said, I have no idea how to get started. And with the first assignment, that's kind of a legitimate issue. And in that case, someone made the following smart suggestion. Said, go to NetBrat and just click on it, and you're going to be given a starter file. And that's always true. I always give you just the basic outline. And so it's perfectly okay to take that basic outline. But now what you'd really want to do is you would want to take this thing here and put it into BlueJ. So now you'd want to fire up BlueJ. Let me fire up BlueJ. So you would want to do that, and I'll make a new project. I think I have this project from last time. Here it is, homework 1A. Yes, here it is. And similarly for homework 1B, you would first go grab your starter, make a new project for that. See, here we have homework 1A, so we'll just make a homework 1B. New class. What was it called? Grow Square Printer. And it is true, when you now write this class name, you really need to pay close attention to which letters are uppercase and which letters are lowercase, because if they don't match just so, it's just not going to work. So kill this, paste this thing in here. And now I'm in good old BlueJ, and I can compile. And now I'll get error messages, and so it can't find this thing. Oh, that's because I didn't construct the square yet. So now I'm in BlueJ, and I'll keep working that. In fact, let me do that for a few minutes so that those of you who had trouble with the assignment get the hang of it. So the next thing now to do is to find the code to construct a square. And admittedly, that was a little bit unfair because you have to read further ahead in the textbook than will happen in the future. It's just at this very beginning, it's a little hard for me to keep everything in sync. So let's, I happen to have an electronic version of the textbook. Let me run that. Chapter 2. That's the best fit. Whatever. So I'm going to be looking for somewhere where we construct a rectangle. Maybe searching for rectangle will be a good idea. And that is over here. Ah, beautiful. Here's some code. So let me paste it in. And I'll compile. Now I'll get an error message, and in fact, at least one of you has gotten that because I happened to note that on Piazza, that it cannot find the symbol variable square. Well, why can't it find it? It can't find it because over here I called it box, and you have to call it consistently, so let's change it to square over here. So we compile it. It's all in BlueJ. We run it. And now it prints something out, and that seems happy. So maybe we're ready to submit to NetBrat. So let me copy it into NetBrat, delete this stuff, paste in my actual version. Okay, now NetBrat says it's compared the program output to test1.out. You don't get to see test1.out. That's just to help me in case there's some issue later. And it didn't match. So the expected one here is unfortunately in gray, which makes it a little hard to see. It wanted to see 50, 50, 100, 100, and it actually saw 5, 10, 20, 30. So that means that the program did not yet pass NetBrat, so we need to work on it. And that's, of course, because I constructed the wrong, it's not even a square, right? It has length 20 and 30, so I need to change this to be 100. 100. And I believe it was 50, 50. So compile it again. It compiled. I like to compile it first. I mean, it's a cheap thrill. Where's NetBrat? Here. So it's well worth knowing the keyboard shortcuts for copying and pasting so you can do it quickly. And now it says outputs match, and there's nothing scary looking here, so that means it's good enough to submit it into Desire, not into Canvas. So now comes the issue, what do you submit to Canvas? And most people must have gotten that right, because I've gotten in for the first time in human existence, I've gotten a zip file out that contained only Java files. That's because I made it so that you can only submit Java files. And Canvas manages to enforce that. So I'm really hoping that all of you submitted the straight old Java files and not like a doc file with a Java extension. But we'll know soon enough. So the other piece of the picture is now one just needs to be able to find this thing. So in my file system, if you remember, I made a directory last time called SJSU. CS46A, and here's the homework 1B directory that was just created when I made that project in BlueJ. See, that's like I said before, it's a benefit to make a separate project for everything, that way they're nicely kept apart. And here's the file. So this grow square pinner.java, that's the one that you need to submit. So when you're in Canvas, then I can't demo this right now, but if you need a demo, put it on Piazza and I'll prepare it next time. Then you just pick that file and send it off its way. Now I realize it would be nicer if BlueJ was directly connected to NetBrat and if BlueJ was directly connected to Canvas, but we're not smart enough to do that stuff yet. So right now there's a bit of manual back and forth that you have to do with those files. All right, so so that was the second one. Let me do the third one really quick, because that one was a little harder, I think. So again, I'm going to ask NetBrat to give me the starter file. I guess it's something. And make a new project. That would be homework 1C. Make a new class. I'm supposed to call it homework 1C. And again, we need to be paying attention to the upper lowercase. kill this, paste in my starter thing. Now, of course, it won't compile because of the dots. Okay, so I need to make a new rectangle. How do I make a new rectangle? Well, I just did one in the other one, so I should be able to copy and paste that part. And it'll be the wrong rectangle, but it's easy enough to fix. Oops. All right, which rectangle did I actually need for that? Let's look at the problem description. I guess 0, 0, 20, 20. No, 0, oh, I have to be careful here, right? It goes from 0, 0.
40 height and 60 width.
Yes. So the width comes first. So it's 20. Although it's not going to make any difference for the area, right? Okay, I was hoping you wouldn't catch that so I could show an error. Okay. Now this one doesn't work. Oops. Well, that's a nasty pitfall here. So it's rect 1. Okay, how do I compute the width? Dot width. Okay, yeah. Right. If I do it like this, the compiler will say, oh, now I get a totally different error message. Cannot find symbol class rectangle. Yeah? Aha, I need to import, and that fortunately can also copy from homework 2B, because over here it is done correctly. Did anyone ask about that in Canvas? I mean, that's an obvious question. We never covered that, that would be a totally fair question to ask, right? So then here was get width, and well, we want the area, so we multiply with the height, and the height we get by calling get height. That's okay. I can have as many spaces as I want. So even here, I could put spaces around it. Yeah.
So Java doesn't see spaces?
No. I mean, you don't want to do it. There's a global shortage of them, but
I have a question.
yeah.
So what is it exactly you're reporting when you say import Java?
What I'm telling it is that when I use the word rectangle all by itself, what I mean with that is java.awt.rectangle. So import is maybe not the greatest term for it. It establishes a shortcut. So that way I don't have to write the full long name java.awt.rectangle. If you didn't want to do the import, for whatever reason, you could take this thing out, and every time you mention rectangle, you would have to say java.awt.rectangle, both here and here, and that would also work. But it looks harder to read, right? You have to read through all these Java AWT things. What's that?
The rectangle is an object
Rectangle is a class.
or a class.
Yes.
You're importing a class.
So yeah, and I wouldn't get too hung up on the importing. You have to, you just have to establish the short name for the long name, and so the import does that. Import says, from now on, whenever I use the very last term in here, I mean the whole thing. Yeah.
Just sort of quick question. So the assignments are basically being checked for grades via a thing that's like NetRec, correct? So
Well, that's not quite true. What the grader does is the grader will run NetBrat, will see the exact same reports that you see, and then the grader has a rubric from me where it's going to say, did the student actually use the right methods? Did the student follow a good style? That kind of stuff.
So we got ahead and at the very end noticed that we were supposed to submit the draft.
Oh yes, then what you're gonna fail the draft, unfortunately.
Oh, well.
Yeah, I mean it's 2 points. So next time make sure that for the draft you submit the draft. It's too complicated. There's 150 people registered in the class right now. It's too complicated for the grader to run the thing both ways and then figure out which is the better one. So yeah, just submit the draft. Yeah.
So I wasn't really sure about this part of it. I was trying to find the area, and so I created two
Oh, I see.
7 equal to the get width and
You can do that. So another possible solution would be to say double width equals rect1 get width, double height equals rect1 get height, and then you would just multiply width times height. And that would be just fine too.
is that a little more inefficient though?
No. And don't worry about whether it's efficient or inefficient. The only question is, which is easier to read or which is clearer. And you might argue for a beginning program, but this is probably kind of a little bit easier to read. And so that might sway you in this direction. But it'll be a good long time before we worry about what is the most efficient way of doing something. Right now, I'm happy if it works. Now, there's actually a third way on how you could do it. Let me show how to do that. And that is to dispense with all of this stuff and simply put the computation in here. So it was width times height. So here, I'm just making the computation right into the call to system out print on. It'll compute it on the fly, pass it on to system out print on, and that'll also work. That is maybe not quite so clear. Oops, width, not width. Yeah. That maybe is not quite so clear, but it'll work just as well. So let's compile it. Which one is it? Almost 3C. And let's run it. And then it prints the right answer. Well, is it the right answer? Actually, that's a good question. I should probably copy it into NetBrat now. The draft here. And here's the outputs match. Now, there was a question on Piazza that I thought was an excellent question. Where the student asked, which of these two rectangles was I supposed to construct, the black one or the blue one? And in this case, the assignment didn't really say, right? So whoever constructed the assignment was not like totally precise. And that's another value of NetBrat. It's very difficult to construct an assignment like a legal contract where absolutely everything is spelled out. And this way, you could just try out both, and whichever of the two matched, then that was obviously the one that was intended. And it only takes a minute to try out both. And that'll happen quite a few times, that the assignment might have just some minor flabbiness to it where it's not entirely precise. And then just try it out, and usually the test cases in there will nail it. And that way, you're never in the situation where you later need to tell the grader, well, this is what I meant. So it's a great benefit for both you and for the grader that you can preview your solutions like that. So you should definitely also do that for the final ones. So let's go towards the way of making a couple of final ones so that you get an idea on how that part works. You'll all need to do this by Sunday night, so I think that'll be more interesting than going through the lecture slides. I mean, I'll go through the lecture slides later, but let's do a bit of coding here first. So, page 1.4, we were supposed to do some kind of an animal that says, hello, junior coder, right? So let's do it. Here's the animal greeter. And, oh dear, how do I know how to make an animal? Let me put here the speech bubbles around it. Really I should be sketching this thing up first, but and this thing kind of looks like an animal, doesn't it? So here's my animal. Now I need to space it out a little bit. Okay, I'll compile it. I'll run it. And isn't it beautiful? It doesn't even line up. So, all right, let me make it line up a bit. Okay, so of course, you're going to hopefully draw a slightly more interesting animal at home. Now, when you're done with it, then one is ready to submit it to the final version. So you click on Final. What's that? And now when we submit the query, Now what happens is that because there's so many different animals that you could be creating, NetBRAT really has no way of judging which of them is cooler than any other. And so all it does, it runs your program and it gives the output. The grader, a carbon life form, will now look at the output and will decide whether it was worthy of being given the points. And so the grader will say, is there an actual animal on the left? Does the animal actually have that speech bubble? And if so, you get your points. If you simply say, hiya grader or something, you might not get the points. That's really up to the human judgment of the grader. Yes, sir?
So we're supposed to print that like it says, but you also want us to make an animal face.
Yeah, something. And, just go to town with it, whatever you want to do. You'll see mine. It looks horrible. You had a question here. Yeah. Yes?
Who's the actual grader?
What's that?
Who's the grader?
I'm not supposed to say.
Is it like another student?
What? It's another student. Oh, yes, it's another student. So, but please do not accost the grader and have any private dealings with them. Or if you do, you should be advised that the charge per incidence is $20. So if you have an issue with the grading, you should let me know. If you feel that the issue is personal, send me a private email. If you feel it's one of those things that just lots of people might have had, you can put it on Piazza. And you've seen what happened with assignment 0, where the grader didn't quite follow the instructions, and then he redid it. There's actually 2 graders, and there might be 3 at some point to see, depending on demand. So any dealings with the grader, please let me deal with that. Other questions? All right. So does everyone have a clue how to do this assignment then? So I can move on to 1B. All right. So in 2B. 1B. Oh, 1. I see. We'll see an interesting error here. All right. So now this grow square printer thing here. So what are we supposed to do? We're supposed to grow it to twice its size, and for that you need to find out how that grow method works. I'll show you how to find that. I have the documentation, the Java documentation bookmarked. You'll see that in the lab on Friday on how to do that, I hope. So here's the documentation. We're looking at the class rectangle. And we're looking at the grow method. Let's make this a little bigger. Here it is. No, that's not the right one. No, it is the right one. It is. So it modifies it so that it is h units larger on both the left, right side, and v units larger at both the top and the bottom. All right, so I had, at this point here, I'm going to show you a secret weapon. We all ready for the secret weapon? The secret weapon is paper. And it used to be, like, your parents' generation knew what paper was. And it's this funny substance that's made out of trees. And so you take an implement called a pen and you write on it, and symbols start appearing. And so it's been my sad observation when I walked through the labs, and even when the lab instructions very clearly called for take out a sheet of paper now, students would listlessly look inside their backpacks, find nothing matching that description, and would just move on as if that exhortation had never happened. But it actually is true that if you want to solve any kind of problem, it is a really important skill to doodle a little bit on paper and to get some idea of what it is that you need to be doing. And the reason for that is that our human brain is not able to keep in its short-term storage more than a few bits of information. So when people say one can remember like 5 to 7 facts in short-term memory at one time, And if you want any more than that, you have to create an extension of that short-term memory. And paper works really well at that. Now, I have to simulate it here. So I have this computer with a pen, so I can run this program that does it. So that would be a second option for you. Of course, you could buy a computer with a pen. They're about $1,000. So maybe paper is a low-cost alternative. So we have the square, and see, I can't even remember where it was supposed to start. Top left corner should be 50-50, and the side length should be 100. And you've just got to draw. There's no other way to fly. So 50-50, 100, 100. All right, now we're going to be calling the grow method to make it into a square that is twice as long. So let's do that. Okay, I'm not going to call the translate method yet because I don't have a clue what it does. So to call a method, you have the name of the object, the name of the method, and then the parameters. This one takes 2 parameters. I want to go from 100, 100 to 200, 200. So let's put that in. And now I'll run it. Yeah. I'm making a couple of purposeful errors here. So now it prints. It didn't grow at all. I didn't print it. That is very true. Oh, because that's another good observation, because I made a typo here. This was supposed to be 50-50. But see, now to understand how this program works, you have to go down line at a time. I made the rectangle. I printed it. And only then did I grow it. So I don't actually know what happened after the growing. So the right thing to do is to print it one more time. So let's compile that. Let's run it. It seems rather too big, right? 500? 500? Why the heck 500? Yeah. All right, so now there is a incredible temptation that comes up at that point here. What is the temptation? No, the temptation is not to do the math, unfortunately. What is the temptation? The temptation is to randomly adjust these numbers to see what happens. 9 out of 10 students at this point, research has shown, will now go in these numbers and say, well, what if I try 20? And that's, in a way, it's good. It's just a scientific principle at work, right? You try things out and see what happens. And sometimes it actually works fine. In this case, I assure you it won't. But it actually is a better idea to look at one sketch and say, what the heck happened? So now the side length was 500. How do we get from 100 to 500? Using that other number, the 200. So apparently it put the 200 here, and it put a 200 here. Right, then the whole thing is 500. And let's verify that, in fact. That means that the leftmost coordinate here was to go from the 50, 200 to the left. That would be minus 150. And look at that. So now we understood what happened, what it did. Now let's figure out what it's supposed to do. What it's supposed to do, it's supposed to make it so that this thing here is 200. And so what do we put here, and what do we put here? 50, right? And so my feeling is when you make the sketch, it becomes pretty obvious that it's got to be 50 just by looking at it. But if you don't make the sketch, I mean, I can't think that many steps ahead, and I've been doing this many times. So, what's that? Yes, it will do that, and the translate will compensate for that. So, let's first of all try this. So we run it. Okay, now the width and height are right, but the x and y positions are wrong. So now let's draw this a little bit more nicely. One advantage of this paper is you have undo. So now it grew it by 50 over here. Let's change colors. Not so much for changing colors. And so now this whole side length is now 200 here and 200 here, but now it moved the origin to 0, 0. Why 0, 0? Because it moved from 50 to the left 50. Now, the call to translate will take the rectangle, and it's not going to translate it into a foreign language. It's just going to move it. Why did they call it translate when they could have called it move? Move would have worked nicely together with grow. That is another one of the deep mysteries of mankind. So now we have to figure out by how much do we need to translate it. So we want to move 0, 0 to 50, 50. And so it seems like that would be a reasonable thing to try. So give it a try at home, call square.translate, and see what happens. Should you call translate first or grow later? Well, for some reason, this one says to call translate first. Now that I think about it, that actually is not... Well, I must have wanted that. No, someone put something on Piazza. That seems like the harder way to do it. So go ahead. I'll just forget if you don't remind me. I will make sure that it doesn't matter, but I would like to be reminded so that I can update this file and it doesn't confuse anyone who's asleep right now. Absolutely. I could have changed the grow method to act differently, but it's not my method. The grow method was written by someone at the time Sun Microsystems many years ago. So it's a pre-existing method, and I have no control over it. All right, so that's part 2. Let's look at part 3. Okay, I'm supposed to make another rectangle. So if rect 1 works like this, it would be rect 2. And now I don't even remember what it was. I'll just put in some random numbers in here in the interest of time. Now I'm supposed to compute the intersection, and the assignment says to call the intersect method. And that's how you call it. And it's, again, how anything works in an object-oriented language. You have this rectangle object. You call a method on it. It's called intersect. And to compute the intersection, you need to give it the other rectangle. So in mathematics, you would write something like... Here we go. You would write something like R1 intersect R2, but in Java you have to, first of all, there's no intersect symbol, and you have to say this one here is the first one, the more important object, and on it the method is called. Even though if you did it the other way around, you would get the exact same result. Then you need to print the result, I believe, and I think I'll leave you to the details. When you have questions, which you undoubtedly will, put those on Piazza. Oh, yeah, I guess I do need to put rect 1. Okay. And there is a twist to this that I'm purposefully not telling you right now, and I'm awaiting the question. So, all right, so that's the way that these things should work. I do realize that you're working here with imperfect information. It's not like a math course where you're first given all of the rules of the game, and only then are you expected to put it to use. But you kind of have to feel your way through with a bit of reading ahead, guessing, asking your friends to put together these answers. And that's just life. It used to be that we would teach it much like mathematics, where You would learn one thing, apply it, learn the next thing, apply it, and 8 years later we were done. But computer programming has become so complex that it's just not really possible in a finite time to do it like that. So you're just going to have to be a little bit used to the fact right now that you simply don't know everything that you're doing. That some things you have to do because it seems the right thing, someone's told you. It's a bit more like learning a foreign language. I don't know how many of you have learned a foreign language, but I'm taking this French course right now, and I can't tell you, I don't understand half of the stuff that's going on. When the teacher rapidly goes on in French, of course, and but I do catch enough that I kind of keep up. So that's the spirit. So sometimes I get emails where people say, they're just terribly demoralized. They don't think they understand anything. And then they go to Piazza, and there's some experts who know everything. And that does happen at this stage of the game, that there are a few people who already have some prior programming experience who appear positively brilliant on Piazza. But trust me, in a few weeks, everyone is going to be in the same boat, and no one will understand anything anymore. So don't be disheartened by that. It really is life. And you should be able to submit enough stuff that you'll get at least partial credit. There were a small number of people, not many, I was gratified to see, there was a small number of people who just didn't want to submit anything. And that's not a good idea. Submit what you can. So there's no reason, you could just submit the files that NetBrat gives you, and you might get a bit of partial credit. I mean, that's the absolute minimum that you can do. If you don't even do that, then I assume that you have no interest in the course. But you could just throw me the NetBrat things right back, and when you do that, you might as well try to get them to work. And you're going to have at least partial success. There's plenty of information on Piazza. And I would imagine that with the information from the video that you can look at, with what's on Piazza, everyone ought to be able to complete or almost complete this assignment, as long as you start early enough. So if like Sunday at like 8 p.m. you say, oh, it's time to start doing my computer science homework, it's not going to work. But if you start early enough, ask more questions on Piazza, you should be fine. All right, let's now finally go into the lecture. So this time I took a long time to go through the entire assignment. I'm not going to do that every time. But if you ask me, if you say, I don't have a clue how to do something, I'll be able to talk on and on about the assignment. You're going to be learning more from struggling with the assignments than from listening to the lectures, so I want to make sure that you do a good job with those. All right, did you take the quiz? Most people did. So in 1.8 we have this notion of an algorithm, and I'll go in there even though it's we're not going to really need that for a short amount of time. So an algorithm is a sequence of steps, like a recipe to do something. Right now the things that we're doing are so simple, like computing the area of a rectangle, that one doesn't really need an algorithm. But eventually things do get a little bit more complicated, and it's a really good idea to first think how you do something before you think about how you program it. So it's a general rule that if you don't know how to do it by hand, you couldn't possibly program it. And so you want to have a sequence of steps how you can do it. Or actually a better analogy is that if you have a younger brother who's none too bright, I am blessed with such a fellow, if I can come up with a recipe to explain it to him so that he just follows my steps and the right answer comes out, that's an algorithm. So here's an example where we want to find out which car to buy. So we have a bunch of cars, here actually 2 cars here, and now we want to find out which one to buy. And if you would say, well, just get the one with the bigger fuel economy, with a better fuel economy, and my brother would say, with a what? And the computer, of course, would say, with a what? It has no conception of what that is. So here's a recipe that says, how many miles are you going to drive it? What is the fuel efficiency that's on the sticker? And that gets you the annual fuel that it's going to consume. Then what is the fuel cost? Well, you need to find out what's the price per gallon and multiply it by the number of gallons. And then you say, we're going to keep this car for 10 years. And so the total operating cost is then 10 times that. And then we need to figure out how much does it cost. So we say the total cost of the car is what I pay for the car and what I'm going to pay for gas for the 10 years. And then depending on which one has less of a total cost, that's the one that I choose. So here's an algorithm that breaks it down into a tedious sequence of steps. That's something that a computer can do. A computer can do these very simple steps. And by writing them down in this form, by hand, you get an idea of what it is that you later need to program. And so there'll be several labs that make you do this with slightly more complicated situations. And so they will say, write out something in pseudocode. And when you run into those labs, the expectation is that you get a sheet of paper and a pencil and really write out something that resembles what you see here, where you say for each car and where you say to compute this, multiply that times that and call it this. And you can just write in plain English, choose car 1. Even though in Java there's no choose instruction. You might say system.out.println car 1 is the better choice. That's how you would say it in Java. But in pseudocode, you just write it so that later on you can easily translate it into Java. You have a question there?
The pseudocode, so we don't have to figure out all the imports and things.
No. You don't write any imports, you don't write any braces, no semicolons, none of the syntax stuff. You just write what is the essence of the algorithm. And the reason you want to do that is twofold. One is that if you can write it down in this form, then it gives you a blueprint on how you're actually going to be writing the code. And secondly, as your pseudocode gets more complicated, you can already simulate it and find errors in it. And it's usually easier to find errors that way than in a complicated running program. So like I said, there'll be several labs that make you go through that. And when they say write something out in pseudocode, you need to give it the good try. We'll also do a few exercises in class with that. And students generally find this uncomfortable because they don't really know what's the rules for pseudocode. For programming, there's very fixed rules. The imports, the braces, public static void main. And for pseudocode, it's not so. And so students find that at first confusing. And we'll go through a bunch of exercises for that. So it's done on paper, with pencil. And so that as a reminder, I will have a few exercises that are not the clicker exercises, but they're really paper and pencil exercises where I'm going to have you write something for a few minutes, and then you just have to hand me down the sheets, and then we'll look at them together. And so be sure to also bring some pencil and paper to every lecture. All right, so here's just some descriptions on how the pseudocode is laid out here. So you see the indentation instead of the braces. You see that the variable names are pretty ad hoc. They don't have to be as formal as in Java. And you indicate results in something that one can reasonably understand. All right, so we're going to be leaving pseudocode for a couple of weeks and come back to that later. So let me get into chapter 2, where it kind of mind-numbingly tells you a whole bunch of rules of the games. Today we're going to be talking about numbers. Next time we're going to be talking about objects and methods calls. So okay, I don't even want to say what any of this is. So there's separate types for integers and floating point numbers. That's a technicality, so you have to just know that 13 is an integer and 1.3 is a floating point number because it has that point in there. In Java, floating point numbers are called double for arcane reasons that you don't want to know. It says in the book. So pretty soon you'll just have memorized that int means it's a number without a decimal point. Double means a number that does have a decimal point. Which of the two should you choose? You could pretty much always choose double, but there's some situations where it makes more sense to rule out the possibility of fractional numbers, and then you choose int. Not usually something that students have a lot of trouble with. So that's a few rules how you format numbers. I mean, it's pretty obvious. You can have negative numbers. You can have, for double, you can have decimal points. In the rare case that you need very large or very small numbers, exponential notation can be used. I don't think we're going to see much of that. You can't use decimal commas. You just have to take them out. Just write 1, 0, 0, 0, 0, 0. You can't use like fractional numbers like that. Just instead use decimal numbers, just like on a calculator. Okay. So you can combine numbers with plus, minus, times, and over. It says numbers are not objects. Don't worry about it. We'll get to that later. Okay, let's ask a clicker question. If you just say like double x, and it's a variable, then it's not a literal. So x is a variable, but 3.5 is a literal.
But why would you have to denote that 3.5 is a literal?
They just did. They
Just made me think that there's some use for numbers that doesn't.
No. It's for numbers. It really isn't a very useful convention. I guess what they want to get at is this string here. They call it a string literal, meaning it's an actual string. It's not a variable holding a string.
Yes, that wouldn't even mean 0.
It's
It's just a string.
a string, and so literal means it is just that thing. It's nothing more, nothing less. I realize it's not the greatest term for it, but it is a precise way of distinguishing string literals from string variables, and that's why I use the term. All right, let me set this up in Piazza while you guys ponder this.
The computer estimates there's 136 people.
What's that?
The computer says there's 136 people.
Okay.
Yeah, so it's easier way to do it.
This goes down. $99. All right, so what's the type of this one here? That's pretty clear, it's int, right? It's also a primitive type, but the type of it is int. What is the type of this one here? Double. If you wanted to have it as a, well, we're not even talking about float, so it's double. What is the type of this one here? It is, but is it string. The type of it is with an uppercase s. Right over here, notice that this is a lowercase s, so it is wrong. All right? So it actually is important in Java. And as a general rule, all the number types are in lowercase. All other types, strings, rectangles, and so on, are in uppercase. Okay, so the correct answer is 4, none of the above. And let's see whether we got anyone who answered that. All right. Well, congratulations. All right. So, yes, so look at these things carefully. And so I just want to get the point across here that how the type names work. Uppercase, they are the class types. Lowercase are numbers. Okay, variables. Now, variables are just like in math. They can hold values. The only exception is in math you call variables x, y, z, a, b, c, and so on. And in Java we give them longer names. We have many more of them, and so we want to have like reasonably descriptive names. So a variable has 3 things. It has a type, a name, and a value. So if we look over here, this variable here has the type string. Notice the uppercase s. It has the name greeting, and it has the value hello world. So here I have a second variable that I call printer. So the name of it is printer. And I'm initializing it with system.out, that friendly object that you can use to appear stuff on the console. Maybe we should have called it console. And now you have to have a type for it as well, because every variable has to have a type in Java. And you have to know what is the type of system.out. I'm here to tell you that type is called print stream. So if you wanted to keep system.out in a variable for whatever reason, then you would declare that as a variable of type print stream. So here we have an integer variable. So type is int, name is width, and it's initialized with 13. Variables can be used in place of the values that they store. So over here, instead of saying system.out.println hello world, I can say printer, that's the variable holding system.out.println greeting, which is the variable holding hello world. Over here, I can say printer.println.width, where printer is the variable holding system.out, and width is the variable holding 13. Generally, you use a variable because you want to use something more than once, and it's tedious to make it or to compute it multiple times. The type matters when there's a mismatch between the type and the value. You get a compiler error. So over here, we have the illegal statement string greeting equals 20, and 20 is an int, but it's supposed to get a string, and then the compiler will tell you that's a type mismatch, and the line simply won't compile. So the remedy is to either change this one here to int, or to change this one here to something. If we really did want to greet someone with 20, which may be the cool thing to do these days, how would you do it? You would put quotation marks around it. So you would put a quote here and a quote here, and then that would now become the string literal 20, and that would be our fashionable greeting. All right, so here we have the same thing one more time. Identifiers are the names of variables, methods, or classes, and there are a few rules for it. You can only use letters, digits, the underscore, and the $sign, but don't use the $sign. You can't start with a digit, so 7 up would not be a valid identifier. You can't use other symbols. You can't use spaces. So in pseudocode, we had a thing that said actual space cost. In Java, if you want to do something like that, the way you would do it is you would write it as actual. And the convention is then to make an uppercase letter instead of the space. And this thing is called camel case for obvious reasons, right? That those letters in the middle look like the humps of a camel. or I guess if you have more than one of a dromedary. So that's all. I don't think anyone has trouble with this. Okay, I'm going to skip this one. You can do this one at home. I'm not adding any value here. All right, assignment operator. Assignment operator changes the value of a variable. So over here I have a variable that I've initialized with 10. So I'm drawing this little bubble picture, and width is 10. Now I'm making an assignment. So first width was 10, and in the assignment I set width to 20, and then that changes it so that now it is 20. So in the book they use these bubble diagrams because that looks nice in the book. We're going to be doing quite a bit of that, and the way we will do it is we'll make a table. We'll say, okay, width starts out with 10, and then we cross it out, and now it's 20. So in the book they look kind of messy when you do them like that. But when we do these things by hand, which we will do many, many times, then that's the format that we'll use. So assignment changes what's in a variable. Think of a variable as a little box. So that's why I like these things in the book. They look like a little box with a name, and they have stuff inside, and you can change the stuff that's in there. But when you sketch it out because you want to analyze what a program does, you just use this tabular form. Okay, uninitialized variables. So over here, I have a variable height, and I didn't initialize it, and then I use it later. I say width equals height. Now the compiler is going to say height has never been initialized, so there's nothing in it, and that's a syntax error. The remedy is to put something in, and yeah, that's really all I want to say here. Okay, the right-hand side of the equal is often a mathematical expression. So over here, let's assume that at this point I have put something into height, so that this is legal. So now I say width equals height plus 1. That means compute the stuff that's here. Oops, there's a typo here. The picture doesn't match the... So let's look at the more interesting expression. Width equals width plus 10. In mathematics, that would be impossible. No number can equal itself plus 10. But in a programming language, this is perfectly legal. What happens is that width plus 10 is computed. So looking here, width apparently was 30, and then width plus 10 is 40. And then that value of 40 is transported back, overriding the previous 30. So if you want to modify a value, if you want the width to grow, then that's how you can grow it. All right, so here we have a clicker question that I do want to do. I want you to know what is the value of x and y after the following statements. And before setting up the clicker question, so the way that, that I would do something like that is I would make a table. I would put up what is x, what is y, and as these four statements gets executed, I would cross out the old ones and put in the new ones. Post. All right, so let's see how we're going to do this. So x, y. X is 10. Here, that's here. 2 times x is 20, so y becomes 20. 2 times y is 40, so x becomes 40. And 2 times y is, y was 20. See, that's why I have to write it down, because I'm too old to remember these things in my head. So 2 times y, y was 20, so 2 times y is 40. And what I do with it, I put it back into y, so y is 40. And the solution is this. So if you write it down on a sheet of paper, you can just do it in a jiffy. All right. So one thing that I wanted to say, why I'm insisting that you learn how to do these kinds of things is the way to analyze a program is to look at it one step at a time and to see what each line does to the variables in the program. And there's all this research that where one looks at who is successful in a introductory computer course, because this not everyone is, and the highest correlation that one finds by looking at various things is, people look at, is someone who's passed calculus necessarily better at this than people who haven't, or people who have a musical sense or something. And so what they have found is that the highest correlation is that people who have an operational feel for what the computer does, people who can simulate a computer in this very boring way, figuring out what happens to every variable a step at a time, that those people have a much higher chance of passing the course than others. So an operational sense of the computer means that you have to be able to simulate the computer by hand by just writing on a sheet of paper what happens. So we'll have plenty of these exercises to make sure that everyone gets that. It's not rocket science, but it is an important activity. And to this day, I do this. I'm faced with code that I don't understand, that's buggy. I take out a sheet of paper, I make some notes, what do I think is in here, and then I follow through how are these things transformed, and I write that down on the sheet of paper. So it's a useful way of reasoning. All right, number 4. Let's see. Oh yeah, this is a great question. All right. Have a look at it while I put it on. So I should say, if you think there's more than one answer, then pick the one that you think is best. All right, let's go through these things and see which ones are correct and see if there's a best of those. So, number 1, correct, yes or no? Yes, right, so let's see. And lots of people think that's the best answer, in fact. So, and it certainly is a correct answer, because that's how you can change what's in the string. You just assign some new value to it. Number 2, yes or no? It can't be right because, and you have to carefully look for this, it has a type again. And it's a very subtle thing. If you do it like this, then you define a new variable. So when you write x equals 5, that means move 5 into the existing variable x. If you write int x equals 5, that means make a new variable of type integer named x and move 5 into that. So this little word here distinguishes making a new variable from changing an existing variable. And you have to pay attention to that. And it's a common error for beginners.
I got a question.
Yeah?
So when you make new integer x, does that write over the old x? Or
Oh, okay, that's another thing. You cannot have in the same method have two variables with the same name. So the second one would actually be a syntax error because the compiler would say you already have a variable called greeting. And that might happen to you that by accident you, like for example, this is what actually sometimes happens. Someone says int w equals 20, and then later they want it to be larger, and then they say int w equals 2 times w. And at that point, the compiler would say, no, go, you already have a w. And so the remedy is, of course, to realize that that's what was happening and to remove it. All right. How about number 3? It looks like there's a substantial number of people who like this answer. And so I would imagine those people already know a little bit of Java and they're familiar with the change to method, except there is no such method. I invented that thing, just to see. So there is no such method. And as it happens, with a rectangle, you can change a rectangle by calling translate or by calling grow, and it changes what's in the rectangle object. With strings, there's no method that changes what a string is. Strings are what's called immutable. Once you have a string object, it can never change. So there's no such method. Now this one here, see if we have anyone who fell for that. We have just a couple. So this is simply impossible. You can't, when you assign to something, the left, whatever is to the left of the equal here, whatever is to the left of the equal must be a variable. The stuff over here is not a variable. Right? It's an expression. So it's a syntax error. So that's wrong too. All right. We ended late yesterday, so let's end a couple of minutes early today. You know what to do for your homework. Any questions, you know where to put it. I'll see you next Wednesday.